Here we're going to look at question 16 from section 2 of the BMAT 2014 paper. So in this question we're told that 3 different classes take a test. The mean scores of each class are 61 for class 1, 63 for class 2 and 70 for class 3. We're also told that the overall mean across all 3 classes is 65. Then the final thing the question tells us is that class 1 contains twice as many students as class 2. So what the question asks us to do is find how many students are in class 3 relative to 1 and 2. So if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at it together. So let's think first of all about the information which we've been given in this question. So we're told that class 1 contains twice as many students as class 2. So let's think how we could write that. Since we're trying to find out how many students are in right 3 relative to 1 and 2 anyway, we might as well come up with a good mathematical way of writing this down. Well, what we could do is say that the number of students in class 2 is just going to be n, and that the number of students in class 1 is 2 times that, so it's 2n. Then the number of students in 3 is just going to be some ratio k multiplied by n. It's going to be some fraction of n. So now that we've done that, let's see if there's anything else from the information we've been given which could help us find an answer. Well, we've been told the individual means of each classes and the overall mean. So let's think about what this overall mean actually is. Well, it's going to be the ratio of each of these means as a kind of proportion of the total number of students taking the test. So we could write it mathematically using these number of students in the following way. We could say that our overall mean 65 is going to be equal to the number of students in class 1 as a fraction of the total number of students multiplied by 61, the number of students in class 2 as a fraction of the total number of students multiplied by 63, and the number of students in class 3 as a fraction of the total number of students multiplied by 70. So this is going to be useful because in this case, while we don't know what n is, we could try and find out what k is in terms of n or something. So let's see if we can simplify this expression and rearrange it for this value k. Well, if we look at our denominator first, our 2n plus n plus kn, then we can, because it's the same for each of the fractions, we can extend it across and simplify it to become 3n plus kn. The tops as well are going to become 122n, since 2n multiplied by 61 just gives us this, 63n, and 70 multiplied by kn. So the next thing to do is just to multiply this denominator by, multiply both sides by this denominator, to bring it up here to the left-hand side, and then we can expand this to give us 195n plus 65kn. Finally, all we'd have to do is bring our k's onto one side and get everything else onto the other side to give us that 10n equals 5kn. So handily at this stage we see that our n's cancel out and we can divide by 5 to get that k equals 2. So what does this mean? Well, if we go back to our number of students in each class, then we can see that class 3 is kn students, so that's the same as 2n students. In which case, what this is telling us is that the number of students in class 1 is equal to the number of students in class 3. They both have 2n students. So this is going to correspond with answer D given in the question.